All right, apologies in advance if this lesson is a little lengthy. There's a lot of vocabulary to get out of the way today, but once we cover that, the actual work and examples goes by, I hope, pretty quickly, and I hope that we can have some quality practice together in class and have a successful unit here, or at least starting this unit successfully with surface area for prisms and cylinders. But in order to do that, we want to make sure that we can understand exactly what we're doing. Our goal today is for prisms and cylinders, just finding the surface area. We'll get to volume in a couple lessons after we do pyramids and cones, but for now, we're going to focus on prisms and cylinders. Some work you've done before, but we're going to kind of try to streamline our thinking, the algebra, etc. There's some key vocabulary terms that we should be aware of. A polyhedron is basically just a three-dimensional object. And a three-dimensional object whose sides or faces, whose surfaces are polygons. Whether those polygons are triangles or if they are rectangles, we want to make sure that we are identifying each of the faces, the surfaces are all these polygons. An edge is where two polygons meet and they make a line or a line segment. That is an edge. A vertex is kind of like the pointy part. Where you have three or more faces added or meeting together. You'll see that there is a vertex at the top of this pyramid, or really at any corner of the pyramid, at any corner of your prism, you'll be able to see where those vertices are. Now, what I'm holding is actually a net. A net is basically a two-dimensional representation of a three-dimensional polyhedron. And so we can take these 1, 2, 3, 4 rectangles and then these two squares and fold them in such a way that they make a square prism. All right? Or we can take these four triangles and one square and we can make a square pyramid. And so this is just a net. Sometimes visualizing a net will make it easier for you to compute the area in kind of that pre-algebra, algebra 1 mindset, all right? So if you get stuck on some of these things, you can always try to redraw the figure as a net and add up the separate areas of the pieces to find the total surface area. Like I said, we're going to try to streamline that, try to make it a little easier today. But those are some basic terms there. Again, we talked about a prism. And so here is, again, a prism. This is a rectangular prism. We can have triangular prisms, hexagonal prisms, etc. And a prism is basically composed of the parallel bases. So in this triangular prism, the triangles are the bases. In this square prism, the squares are the bases. In this hexagonal prism, the hexagons are the bases. Even if it's laying on its side, this is not the bottom, all right? This is the base, the parallel and congruent, not necessarily rectangular faces are the bases, all right? Now, the lateral faces are basically all of these other rectangles. The sides in your prism will always be rectangles. All right, and that's really helpful because then it helps you identify where your lateral faces are. All right, in this triangular prism, the lateral faces are all rectangles, and we know how to find the areas of rectangles and the areas of triangles, so we should hopefully be able to do this task that's before us. Now, the altitude is a segment that runs perpendicular between those parallel bases. All right, again, these triangles are the bases, and they are parallel to one another. And that perpendicular distance between those parallel faces is the altitude. We usually label that the height. Height and altitude they're very similar concepts. The height is the length of the altitude. So hopefully that won't be confusing. Sometimes they say like the depth or the maybe even the width. We'll say like, oh, how wide is this prism? And what they're talking about is what's the distance between those parallel faces, especially if this prism is laying on one of its lateral faces. All right, so kind of keep that in mind as we work through this. When we're referring to prisms, there are right prisms, oblique prisms. We're typically going to be working with right prisms. That's where the faces are perpendicular to each other. You can have oblique prisms where perhaps the bases don't stand directly above one another, and so they can kind of seem a little wonky. And that would, sorry for the terrible drawing, but that would be an oblique prism where the bases are not flush 100% directly vertical from each other. All right? Now, the lateral area is going to be the areas of all of these rectangles, all right? All of these rectangles will be the lateral area. These areas of the triangles will be the area of the bases. Add them all up, and together you get the surface area, all right? And that's actually what brings us to our first formula. Our first formula is when we take that lateral area and we add on the area of our two bases. So I want you to write down this formula. You don't have to write down all that text. But what you're going to notice is that the lateral area is kind of an interesting concept. Instead of saying, well, I need to find the area of this rectangle, and then I need to find the area of this rectangle, and then this rectangle, and then I need to add them all together, that is not a difficult task at all to do. But what if it could be a little bit easier? What if we could make that go a little bit faster so that we're not having to find the area 4 times and then add those 4 areas up? So what we want to do to streamline that is we can find the lateral area by taking the perimeter. If you look at the perimeter of this triangle, the perimeter of this triangular base is essentially the base of this really big single rectangle. One big rectangle, not 3 separate, but one single rectangle. And then, of course, the height of our prism is the height of the single rectangle in the lateral area, all right? So what I mean by that is, if we were to take our triangular prism, and instead of it being 3 separate rectangles, what if we recognize that this and this were congruent, that this and this are congruent, which again means those are congruent, these are congruent, and then this side is its own thing. What we should notice is that this total length here is the perimeter of the triangular base, the perimeter of the base. All right? And so instead of finding 3 separate triangles, what if we just took that perimeter of the base and multiplied it by the height of the prism? All right? And that essentially would give us the lateral area. Then all that we need to do is add on the areas of these 2 triangles. Instead of finding area, and then adding them all up, we can just do 2 products. The perimeter of the base times the height of the prism plus 2 times the area of the bases. All right? All right, because those bases are congruent, so we can do that. All right, okay, moving on with that concept. We're going to do a couple examples here, working strictly with prisms. We're going to see how this goes with our prisms. And the first one, I think, generally speaking, the rectangular prisms are a little bit easier. The triangular prisms tend to be a little more difficult for whatever reason. And so we want to make sure that we do a good job of this. Really, with a rectangular prism, any of the faces can be the bases. Most of us are comfortable saying that the bottom is the base. So I want to kind of challenge you a little bit to say, like, what if the bottom were not the base? Like, what if I said that this side were the base of this prism? Does that change the surface area of this figure? All right, and so I want to encourage you to try. You can try this 2 ways. I'm going to do this one saying that this side right here is our base. All right, so this is 5 centimeters this way, and this is 3 centimeters that way. So these are our bases that I've shaded in. The perpendicular distance between those bases is 4 centimeters. So this is going to be the height, all right? This is going to be the height. The perimeter of the base is going to be 3 plus 5 plus 3 plus 5. You can either add them all up, or you can multiply 2b times 2h, or 2l and 2w, however you want to do that. But basically we have 3 plus 5 and then double it. So our total perimeter of our base is going to be 16, all right, with our height of 4. So if I'm finding that my surface area is the perimeter of the base times the height plus 2 times the area of each base, then when I do that, I can take my 5 plus 3 times 2, all right, 2 times 5 plus 3, that's our 16, and then multiply it by the height of 4. And then add on the area of my 2 bases. Well, my 2 bases are the 3 by 5 rectangles. And so this is going to be some quick calculation that you can just type as is in your calculator if you're a fan of mental math, as I am. And you can do 2 times 8 makes 16. 16 times 4 is 64. And then you have 2 times 15 is 30. And you can add all those up and you find out that the surface area is 94 square centimeters. All right. Now, if we were to do this differently, using a different base height combo, what if we said that these were the bases? That this here and then this that goes on the bottom is the base. Most of us are going to try to do it like that. All right? Well, the math works out the same way, where we're going to end up with the same surface area, just using a different side, a different face of this prism as the base. All right? Same formula. So let's talk about how this will go for us. All right? I'm going to erase this a little bit more cleanly. All right? The area of our base is going to be 4 times 3 makes 12. The perimeter of our base is going to be 4 plus 3 makes 7 times 2. That's our perimeter. And then our height, how tall this is, the perpendicular distance between these parallel bases is 5. All right, so this gives us 14 times 5, which is going to be 70. And then I need to add 2 times 12, which is going to give us 24. And these all add up to 94 square centimeters. All right, so in a rectangular prism, you've got some flexibility as to which face is the base. Most folks are going to pick the bottom. Why that becomes dangerous is because if I were to ask you to draw a triangular prism, most of you would draw a triangular prism that looks something like this. All right, and now what is the base? Well, if you paid attention to the vocabulary a couple slides ago, you would note that the bases are the triangles. All right, the parallel, congruent faces that are not the rectangles necessarily are going to be the bases. So even though it's lying on the bottom, that rectangular bottom is not the base of this triangular prism. All right? So we need to be very aware of that. Maybe we want to draw a net. Maybe we want to try to draw the figure. Do your best to try to draw these figures as best you can. And let's see how we do. But the triangular prism has an isosceles triangle for a base. All right? And those isosceles or congruent edges there are going to be 5 centimeters each. Right, so these are 5 and 5, and then this is 6. And then the depth is 12. All right, that's that perpendicular distance between these triangular faces. All right, so how do we find the surface area? Well, the surface area is found by taking the perimeter of the base times the height plus 2 times the area of the bases. So the perimeter of our triangular base is 5 plus 5 plus 6. That is not a trick question. That's as easy as finding the perimeter of the bases. The height of this prism is 12, all right? It's not how tall the triangle is. It's how tall the prism is. The perpendicular distance between those parallel faces is 12 centimeters. Now, that's the easy part. The hard part here is actually finding the area of the triangle, which seems insane, right? We know how to find the areas of triangles, so let's do our best. Well, the thing that is hard about this particular situation, if this is 5, 5, and 6, then we do not know what the height of this triangle is. Not the height of the prism, but the height of the triangle. We have to keep our thoughts straight here. So when I draw in this altitude, what we notice is that this is an isosceles triangle, and so when I draw the altitude, it cuts that 6 into 3 and 3. And so by the Pythagorean theorem, I know that the height of the triangle, the height of the base, not the height of the prism, the height of the triangle is 4, because we have a 3, 4, 5 right triangle. If you want to do Pythagorean theorem there to find out that's 4, you can do that. I think that's not worth our time at this point. So now we know that the area of this triangle is going to be 1/2 base times height. So 1/2 times the whole base of 6 times the height of 4, all right, is going to give us that total area. So 2 bases, 1/2 times the base times the height of this triangle is 4 centimeters. We need to know where all those numbers come from so that we can do this when tasked with doing it on our own. The surface area is 16 times 12 plus 2 times half of 24 is, again, 12. And so we can do a little quick calculation here. 16 times 12. I know it's not on our times tables, but we can still do that. 16 times 12 gives us 192. 2 times 12 gives us 24. And then we can add those together to get our total surface area. All right? 216 square centimeters. All right? And so this is how we find surface area for prisms. All right? This is just the prism part, so sorry that took long. That was about 15 minutes. Woo! But we're going to keep cooking because we're going to get to cylinders, and it's going to go a little quicker because we're going to understand this concept of bases and heights and parallel faces, etc., lateral area. When we're talking about cylinders, we're talking about 3D figures whose bases are circles, all right? But what's awkward about that is that we then have this kind of rounded lateral area. Like, what do we call that lateral thing? The altitude is still kind of that same idea. It's that perpendicular segment that is drawn between the parallel faces. And the height, or I'm sorry, the length of the altitude is our height. Our cylinders might be like so, they might be like that, they might be oblique. Typically, we're going to deal with right cylinders, and so not the oblique cylinders. And the lateral area of our cylinder is a rectangle. Now, I've done a little bit of work with this already, showing you all that the lateral area in a cylinder is indeed a rectangle when I showed some work with our handy dandy paper towels. You know, when we are trying to clean our desks between blocks, we notice that we are not given kind of awkwardly rounded paper towels, but in fact, these paper towels, when we unwrap them, if I were to put a little cut right here at the same spot where we started, we're going to notice that when I cut that it is going to create, don't stab yourself, Mr. Ibbott, that we're going to create, I think I'm doing okay, I'm not going to hurt myself, that when I cut that, all right, so here is the paper towel roll. I did a nice magical deep cut there, it's a deep cut. When I pull that out, it turns out that lateral section is actually a rectangle. All right, now look how huge this rectangle is around that cylinder. Well, we're going to be able to find the area of this rectangle by taking the circumference, how far around it went, all right, times how tall the cylinder is, or the height of the cylinder. So it's kind of a fun concept. And we just have to kind of visualize that when we unwrap the cylinder, we make one giant rectangle that has the perimeter, I'm sorry, the circumference, the 2 pi r, as the base of that rectangle, and then the height of the cylinder as the height of this rectangle. So computing this area is not, hopefully, going to be too challenging. The surface area for a cylinder is that lateral area, circumference times the height, or 2 pi r times h, plus 2 times the area of the base, 2 times pi r squared. Now, we don't have to worry about, like, specifically for a cylinder, it's 2 pi r h plus 2 pi r squared. I don't want you to worry about that. If you know the circumference, and if you know the area for a circle, if you know those formulas, then we don't have to memorize a special formula for cylinders. It's the same as the formula for prisms. It's just we replace perimeter of the base with circumference of the base, because circles don't have circles don't have perimeters, they have circumference. And so it's the same formula for cylinders as prisms, except that the concept of perimeter is called circumference when dealing with circles. All right? So the formula is basically the same, all right? And so we're not going to call it pH plus 2b. We're going to say the surface area is CH plus 2b. All right? Here we have a cylinder with a height of 11 and a radius of 4. So when I take my circumference there of 2 times pi times the radius, and I multiply that times the height, plus I take 2 times the area of the base, pi times the radius squared. We're going to do this work again in terms of pi. And so this might be a little bit challenging for us. Basically, we're going to ignore the pi in here. We're going to do 2 times 4 makes 8. 8 times 11 makes 88. And then over here we get 2 times pi times 16, or 2 times 16 is 32, times pi. And then we can add those parts and pieces together. We're going to treat pi like it's the variable x. And if we had to multiply and add these things together, we'd say, hey, these are like terms. I've got 88 x's and I've got 32 x's. And when I add those all together, that gives me 120 x's. But it's not x's in this case, it's pi, and we're dealing with square units. All right? So sometimes things work out very nicely, where we have the circumference 2 pi r times the height plus 2 times pi r squared. Other times we're given the diameter, and then things get a little bit messy. All right? The surface area is found by taking by taking the circumference times the height plus the area of the two bases. And so in this case, circumference is just pi times the diameter. All right, the height here is 10, but the area is going to get a little messy here. The area of the circle here is going to be pi times our radius, which again is that diameter cut in half squared. Oh no, so now we have to deal with this fraction, all right? But we're gonna handle it because we have technologies that can, or we get to do our elementary arithmetic. Either way, we're gonna be okay with that. I know that that's a bit of a struggle sometimes, so use the technology. Pi times 7 times 10 is 70 pi. Over here, we've got 2 times pi times 49 over 4. All right, I know that's a little bit awkward. If we were to multiply 49 fourths by 2, that would give us 98 fourths, but then that would simplify so that we would get 70 pi plus 49 over 2 pi. But now we still have like terms, it's just that they don't have a common denominator. So we're going to use our calculator to take 70 plus 49 divided by 2 and make sure that we write that as an improper fraction. Now, just a little hint there is that we can make sure that we do a good job here by calling this 140 pi over 2. All right, if we make a common denominator, it makes the process a little bit easier. But that again goes for those of you that you get that elementary arithmetic. If you're having trouble adding these, use a calculator to do it. But if you take 140 pi over 2 plus 49 pi over 2, you get 189 pi over 2. 189 pi over 2. And this is in square centimeters, I believe. All right. So we want to make sure that we do a good job with that fraction work. All right. Do our best work with that, and then life should be bueno. All right, folks, that is the end. If you have questions, ask. Send me an email or talk about it in class. If you need to watch part of this video again, go for it. But our goals were to make sure that we could find the area for prisms and for cylinders, and we have done that.